So, hello guys, with the name of God Ram Ram. Obviously, Google for their SDE interviews loves to ask graph and binary search problems, right? And the problems they ask, they are always the thing I like the most about Google is that they always try to ask newer problems, hard unseen DSA problems, which you cannot solely do by just memorizing the standard questions from the standard DSA sheets. Okay. So I like the fact that, they ask the candidates for actual raw problem solving skills, thinking skills, you know. So here we will try to see how can we think through this problem. Okay. Rather than just explaining you the solution, I will try to explain you the intuition and logic and how to come up with it. Also, I will try to show you some cases which clears it up that why other logics or faulty logics cannot work. Okay. So obviously, before I start doing all that, you should take a look at my prerequisite course. If you have done the basics of programming, all you need to do is the best DSA warm-up course of DSA plus OA plus CP in our country, India, Bharat. This is it. You need to start from here. Many good quality videos are there of all the topics, and different company OA sessions and interview sessions are also there. Complete them. This graph list of these 6 videos is very very important to build a very strong foundation. Watch them. I have taught many things there, many important BFS DFS tricks you might not be knowing, so make sure you look into it. Once you have done this, then you can, watch this video. Then you will get the best value out from this video. Okay. Now, what was the problem? Rescue mission in the grid city. So it was asked in Google SG3 interview. It can, fetch you a CTC of 65 lakhs to 85 lakhs easily. You are given a city represented as a matrix n cross m grid. Okay. Either the cells can be dot cells, or they can be, hashtag cells, or the start cell, or the ending cell, or the fire cell. So before I discuss this problem, let me create a simple matrix for you people. So they are saying that a simple matrix will be there in this problem for you like this. Okay. Okay. Then there some cells will be dot like this. One of the cells will be E, one of the cells will be S, then other cell, like one of the cells will be S, other will be E. Then some cell can be, hashtag cells also. So they are asking you that the minimum amount of seconds it will take you to go from start location to end location. From the start cell, you have to reach the end cell in minimum number of seconds. Now, what type of moves are allowed? From the start cell, you can go in any one of the 4 directions. In 1 second, you can go to right. In 1 second, you can go down in 1 second. You can go left in 1 second, and you can go up in 1 second. Okay. Okay. Fine. So in this particular matrix, what do you think? What is the minimum number of seconds needed to go from start cell to end cell? Also, please know that you cannot go through the cells which are hashtag cells. Okay, you cannot go through the cells which are hashtag cells. They are blocked cells. You can only travel the cells which are having the notions as S, E or dot. Only they are the cells which are allowed to visit. So the answer is pretty simple. You just need to know the shortest path, right? In this grid, you just need to know the shortest path from S to E. You just need to know the shortest path from S to E, right? So what is the shortest path? The shortest path which follows the rule that you can only go in the up, down, right, left, all these 4 directions, left, right, down, up. left right. Okay, so from S you will go here, then you will go here, then you will go here. So what is the path length? 1 2 3. In 3 moves, one right move, then one more right move, and then one down move. In RRD, in 3 seconds you will be able to travel from start to end. Okay, but you should be careful that you can never visit the, you might be saying, sir, why did you not take this path? From S you go down and then you go right and then you go right. Why did I not take down, right and right path? Well, there is a reason. If I go down from S, here is a blocked cell. You are not allowed to visit the blocked cell. Okay. So I can basically I have to find the shortest path from S to E such that you don't visit any blocked cell. So this is a very simple problem, right? I have taught it in the prerequisite course. The link I have already showed it to you. Okay. If you have done all this, now you will understand what I'm going to say. If you have not done this, do it and then come back to my video. So we will convert this grid to a graph basically. We will convert this grid to a special graph. Okay, no problem. So we convert the grid to a graph. So basically all the cells which we have now, we will represent them as circles, nodes. Okay, this node is dot, this node is S, this node is dot, this node is dot, this node is hashtag, this node is dot, this node is dot, this node is E, this node is dot, this node is hashtag, this node is dot, this node is dot. Okay, now guys, you will start making edges. You have to assume it as a graph. So which type of edges you will make? If two nodes are having dot value and they are adjacent to each other, you will make an edge like this. This means you can travel from here to here in 1 second. The edge represents that you can go from one dot node to any other adjacent dot node in 1 second. If this dot node is here and another dot node is down below, you will create an edge like this. So basically in the 4 directions you will create the edges from a particular dot node to other dot nodes, because you can go in all 4 directions, right? And also if there is a dot node and then there is a S node, you can make an edge also here, like from dot to S also, because going from dot to S is allowed. If this is a dot node and this is a E node, then also you can make an edge. The only caveat to this problem is that you cannot make any edge from any dot cell to any cell which is a hashtag. This edge is not allowed. Why? Because you can never travel from dot node to hashtag. From any node you can never travel to an adjacent node which is a hashtag. Hashtag means a block cell. So you will make edges in such a way such that there is no edge made to incident to the hashtag cell. Okay. So how will I make the edges? Ram Ram. So first all the horizontal edges I will start making, right? Yes. From dot to S, from dot to S, then from S to dot, then from dot to dot, right? But here the horizontal edges will not be there here, because with hashtag you cannot make. But yes, from dot to E you can make. Here, no horizontal edges. Now vertical edges. Yeah, this, okay. As to hashtag you cannot make. Hashtag to hashtag, no. If any of the cells is hashtag, the edge cannot be made between those two cells. Dot to dot, yes. Dot to dot, yes. Dot to E, yes. Now the question is very simple. Each cell, it can be represented by I comma j, right? I have not given the numbering, but I hope you understand the numbering in a grid. Okay, or a matrix n cross m. This is n and this is m. Okay, this m is equal to 4 in this case and n is equal to 3 in this case. Okay, this is these are our initial observations. Okay, so these things we understand and these things we are doing. Okay, fine. So in this graph, you just need to do breadth first search algorithm. BFS will find the shortest path because the graph which we have created is unweighted. and undirected. Basically, each edge means you can go from here to here also and here to here also. And also there is no weight. We are assuming that each edge weight is just one. Okay. So in this graph, you will start BFS from S. Breadth first search algorithm, you will start from node S. Breadth first search algorithm, you will start from node S. Okay. If you don't know about breadth first search, please go to my prerequisite course and study from there. Okay. From here. So when you do BFS from S, what's going to happen? It will be able to find the shortest path from here to here, here to here, and then here. Even this is the shortest path from here to here, then down, then right. So it will find the shortest path 1, 2, 3, and it will give the answer as 3. Okay. So you just need to do BFS from the starting node once your graph has been made. Now, this graph, you do not have to make it in real. You can just use a special grid on graph queue technique to generate the same effect as this graph. But in your mind, you need to know that you have created a graph like this and then you are running a simple function which is BFS from the start cell. Let's say the start cell here is what? 0, comma 1. So it will be BFS starting from 0, comma 1. And now the distance matrix will be able to tell you the shortest distance from S to all other nodes including E. So whatever is the distance of the shortest distance from S to E, you will be knowing that, you will print it. Okay, problem solved. But now there is another problem coming up for you people. The another problem is that there can be a fire node also. There can be a fire node in this problem as well. That's what they are trying to tell you. There can be a fire node as well. There can be a fire node as well. So fire node will start spreading the fire. Fire node will start spreading the fire. In all four directions simultaneously. So how do I explain you this phenomena? Just give me a second. Let's say the matrix is like this, okay? Let's say this is E, and let's say this is let's say this is E, okay? This is start node, this is end node, okay? And this is the fire node. Now fire node means let's say all other nodes are dot nodes. Okay. Hashtag you already understand, so I'm not making any hashtag node. If you want, I can make it like this. This is F. So now you might be thinking that you will travel from the shortest path like this and you will reach the end node. But now the fire is also spreading. Can you see this fire node F? At t equal to 0, at 0 seconds, the fire is at this location. So I will represent with the blue color that in which cells the fire has come at which time. Okay. So yeah, listen. Let's say in this cell the fire has come at t equal to 0 seconds. Okay. At t equal to 1, it will spread in all the four direction. Up also, so at t equal to 1, the fire is there in this cell. At t equal to 1, the fire has spread to the right hand side also. At t equal to 1, the fire has spread to this cell also. So guys, do you understand that at t equal to 0, the fire has been lit in one of the fire cells. Okay. But now at t equal to 1, at t equal to 1, fire will be going from that particular cell in all the four directions. So At t equal to 1, the cells which I have written with the blue color one, they have also been fired. Okay, they have also been fired. Now what? Again the fire will go in all four directions. From this one it will go up, right? At t equal to 2, fire is here. At t equal to 2, from this node it can go here also, right? The fire on the right hand side. Wherever there is a 1, now it will push in all four directions. So in this, for this one, 1 up, 2, and at the right 2, at the bottom it cannot go block, and in the left it will not go, because in the left the fire is already there at t equal to 0. Okay, now let's consider this one. This one will put a fire on the right hand side at 2, but there is already a 2 there, so no need to do anything there. No need to go below, because at below t equal to 0, fire is always already there. Yes, you can go up from this one and you can declare fire at here t equal to 2. And from this one you cannot go anywhere, because left there is no cell, right there is block, down there is no cell, and up there is a cell, but the cell at the upward already has a fire at t equal to 0. So guys, can you see this diagram and understand that when everything starts at t equal to 0, then t equal to 1, then at t equal to 2, can you see what is happening now at t equal to 2? At t equal to 2, in this matrix, all the cells with blue color are have been fired. You can never visit a cell which has been fired. You please know that thing, okay? You can never visit a cell which has been fired. Now what do you think? Will you be able to reach from S to E? Let's see. If you did your BFS from S to E, in 1 second, in 1 second you would reach here, right? In 2 seconds you would reach here. In 3 seconds you would reach here. In 4 seconds you would reach here. In 5 seconds you would reach here, right? 0, 1, 2, 3, 4, 5, 6. In 6 seconds you can reach E, right? But at t equal to you have seen this much, right? You can go from start to end in 6 seconds. But in t equal to 2 seconds, all these cells have been fired. Do you know which cells will be fired at t equal to 3? The fire is at this now, from 2 to right. This 3 has also been fired. This 3 has also been fired. The end cell has been fired itself. The end cell has been fired itself, and this also has been fired. So guys, by t equal to 3, your end location has been fired. So you will reach here, if you follow the normal path from S to E, you will reach at t equal to 6. By then this would have already been fired. Hence in this case it is not possible to visit from S to E. The answer is -1. So obviously you are trying all type of shortest paths from S to E. Okay. But it can very much happen that you are not able to reach from S to E. It can very much happen. Okay. Because the fire came in between of the way. So now how do you solve this problem? The main intuition of the problem is that we will do BFS from fire to see how the fire is spreading. We will forget about S to E and we will only see how the fire is spreading. Okay. So if I like try to take this big matrix for you people, okay. Let's say this is S and that is E, something like that, okay. S and E. And there are so many cells like this, right? This is the fire. So you will do BFS from the cell which is having fire, and you will try to calculate for each cell fire of ij value, which should tell you what is the minimum time in which the cell I to j is fired. If the cell I to j is fired, it means it cannot be used anymore for traveling. So this you will do BFS from fire. So the fire will spread in all four directions, right? As per the rules. If you do the BFS from here and you keep on marking the nodes which you have traveled. So at level 0, this has been fired. Then at level 1, this is fired, this is fired, this is fired, this is fired. Then at t equal to 2, this is fired, this is fired, this is fired, this is fired, and this is fired, okay? And this is fired. So I hope you can get the hint. With every ingoing and outgoing breath, chant the name of God, Ram Ram, and you will get the ultimate happiness and moksha. Every ingoing breath and every outgoing breath, like this. Always do it daily in the morning for 15 to 25 minutes and see your life changing. Anyways, guys, in this grid, can you see 0, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2? What does this denote? You will do the BFS from fire and you will make a new matrix, fire matrix. In this, you will write this number 0, this cell will have the value as 1, this cell will have the value as 2, and things like that. Now, because of that, what is going to happen is that you will always know that each cell is getting fired at which time. Okay, each cell is getting fired at which time. Once you know that, let's say now you know each cell is getting fired at which time. Now what you will do, once the BFS of F is done, now you will start the BFS from S. Now you will start the BFS from S. BFS from S means you will start the traveling from S to E using the shortest possible paths. There can be multiple shortest paths. BFS explores all the shortest paths, fortunately, if implemented correctly. So now, guys, you will calculate Tij. Tij should tell you shortest time required to go from S to the cell I comma j. So let's calculate Tij. I will write the Tij values with green color. So you are at cell S at 0 seconds, right? From here you can reach at this cell in 1 second, and at this cell you can reach in 1 second. Okay? From 1 you can reach this cell in 2 seconds and this cell in 2 seconds. But guys, can you see the problem? For this particular cell, Tij is 2. Tij is what? 2. Tij 2 means from S to this cell you can reach in minimum 2 seconds. But Fij is also 2. Means at t equal to 2 this cell is on fire. So if you reach it at the same time you will die. Hence the BFS needs to stop from S. While doing BFS from S, there is one very simple condition. See, when you are doing BFS from S, you have to use the U to V trick, right? This is node U. This is node V. Okay. And this is the start node like this. It's a big freaking graph. These strategies I have explained in my prerequisite course, in my 851-hour course, and all that, those things. Okay. Let's say this is your E in the end. Okay. Now, let's say you know the value of T of U. You know how much time it's going to take, shortest amount of time to go from S to U. Now you are going from U to V for the first time. So you will calculate T of V as T of U plus 1 in your breadth first search, right? If you reach here in T of U time, so one more second you will reach from U to V, right? Because U and V are directly connected. But guys, once you know T of V, you cannot relax. You cannot relax. Why? You have already pre-calculated F of V, right? F of V. F of V means at what time is this going to get fired. So if T of V is less than F of V, then you are safe. Then you can safely do your BFS algorithm which is BFS of S. Why? Because T of V is, let's say, 4 second and F of V is, let's say, 5 second. Means you are able to reach from S to V in 4 seconds. And V is getting fired at 5/5 a second. So you will have no problem because you have already visited it at T equal to 4. So whenever you are doing BFS of S now, always make sure that T of your node should be strictly lesser than F of the node, the firing time of the node. The minimum time in which you can visit the node T, visit the node, should be strictly less than the time in which the node gets fired up. Such a brilliant logic. This you will not see in standard DSA sheets. That's why I want you to watch my videos regularly and develop your brain and get a good, great package in life. Enjoy your life, man. Enjoy your life, bro. Now, these things are clear, dude. Okay. So, the final solution is pretty simple that you will run a BFS from S, right? First, you will run a BFS from F and you will calculate all the F of ij values. Then you will do the BFS of S. And in the if condition, when you go from node U to V, you must be knowing, right? We write while loop, then not Q, not empty, then something like this. Then if this node is getting visited for the first time, you write some inner condition, right? Here you will always check if T of V is less than F of V, you will continue the normal BFS. What you will do? You will push Q dot push V. You will push this node also to your BFS because it is eligible. You can visit it in the minimum time. And you will continue the algorithm. But else condition, if T of V is greater than equal to F of V, basically you are saying that it got fired in 3 seconds and you are visiting it at T equal to 5. It means you are going to die, right? So in this condition, now you will not push this node V to the Q. Why? You cannot continue your BFS from node V because if you go to node V, you will die. So at those times, you have to treat the node V as a hashtag node. Hashtag node means you cannot visit it. Though in reality, you can visit it, but fire is coming at node V before you come. That's why you cannot visit it, and that is the solution. Now, one more thing might come to your mind that, sir, why are we only trying for the shortest paths when trying to find the best path from node S to E? Why are we only trying to find the shortest path? There might be some longer path which leads us from S to V and which is able to, dodge the fire also. Dodge the fire also. But actually, this is not possible because of the definition of the fire. Fire spreads in all four directions each second. So even if you try to act extra smart now, you are not going to dodge the fire. So the best way ahead is to go via the shortest paths only. In short, let's say there are 100 shortest paths from S to E. There are 100 shortest paths from S to E. There can be multiple shortest paths, right? Let's say S like this, E, S, E. Like one more node, let me add here. One more node. S, E. In this case, there are three shortest paths, right? S1, there are three shortest paths. You can see it, right? This is the first shortest path. All the shortest paths are having length 2 only, right? Three shortest paths. Now, only one of the shortest paths will be the final answer. Why? Because, let's say a fire node is kept here, okay? Fire node is kept here, okay? Okay, for better example, I think I should take three nodes. Let's say one more node is there. Let's say I'm just thinking where to keep the fire node for you people to just make it little easy for you. So there are those three shortest paths. Okay. Now let's say there is one big longer path also like this, and let's say the fire node is kept here, or I want the fire node to be a little bit away so that it does not create much problem. So let's say the fire node is here. Okay. In 0 it is fired here, then at t equal to 1 these two nodes are fired, at t equal to 2 these two nodes are fired, and at 3 equal to 3 even the start and end is getting fired, right. So let's say this node was not there and this was directly connected to this. So whatever is the shortest node path na from S to E, like in this case again we have only one shortest path. This to this, at 1 second you reach here, and then at 2 second you reach here. Like it's equal to 0, t equal to 1, t equal to 2, at t equal to 3 you reach here, right. And let's say there was one more node here. Okay. So fire node 3, and then fire is getting to the end at t equal to 4. Okay. Let's say something like that is happening. Okay. So now the things are pretty simple, right? You will just go from the start node to, like, what I'm trying to say is that your final answer will always be the shortest path from S to E only. You just have to make sure that you find such a shortest path such that none of its nodes gets fired before you can visit it. That's it. Okay. And the longest paths are not going to work in general. Why the longest paths are not going to work? Let's say you are at this node S and this is E and this is F. Okay. You might try to outsmart S by going in the opposite direction. Let's say you're trying to go the longest way. There is no concept like longest path in this case, but still it can be. Let's say you are trying to go in opposite direction, and then you are thinking that in opposite direction you will go and then you will reach E. That way you will escape fire. But fire, if you go in opposite direction, so you spend t equal to 1 in going opposite direction, t equal to 2 in opposite direction, t equal to 3 in opposite direction. What does this all signifies? All this basically signifies that you have gone in the opposite direction for 3 seconds, but the fire is spreading in all four directions. So in t equal to 1 fire spread this much, in t equal to 2 fire has spread this much, in t equal to 3 fire has also spread 3 seconds in the reverse direction in this full perimeter. Okay. So now when you go down and try to come back, till then fire would have come here down also. And your path to E will be blocked. So you cannot use any kind of smartness, because whatever time you are using now to go away from the end destination, fire is just keep on getting bigger, and wasting time is not going to help you. So it's always better to opt for smallest path from S to E. There might be multiple shortest paths, you can opt for any one of them, but only one of them can be the answer. That's it. Now the follow up for this problem was that there can be multiple fire sources. I will explain you the solution for that also. If you want the part 2, let me know in the comments. Okay. Please like, share and subscribe if you gained lots of value from this problem. Everything is there in the document, and if I try to show you the implementation, let's go to the implementation part. So if I go to the implementation part, hopefully it just opens up. Okay. Yeah. So you can see that first, obviously are tracking SE and F, right, in the C++ code. Then I'm doing BFS from fire and filling the fire cells. You can see. Now once the fire cells are filled, I will smartly do the BFS from the source node S, right? And I will only push those nodes in the queue such that our total time value is less than fire of that cell. Fire, when it's going to get fired. And guys, that's it. That's the answer. So hopefully you like this Google SD3 interior problem and you like this brainstorming. So with the name of God, Ram Ram. Please have faith in God plus good health plus good mindset. Ram Ram.